To learn more about earning college credits with study hall courses, visit gostudyhall.com or click the link in the description. I am a cat owner, which means that I know a lot of weird facts about my cat. I know how much he weighs when he needs to poop, the hours he's sleepy enough for me to safely cut his nails, and the fact that he would definitely eat my corpse if I died. But what if I want to store these facts? Classes are powerful tools in Java, partially because they help us organize a bunch of different data types in one place. For example, if we have a cat class, we can store data about a cat's color as a string, its chonk scale as an integer, its nicknames as an array list of strings, and whether it's alive or dead as a boolean. Sorry, Schrodinger, we're not gonna mess around with the quantum superposition today. Obviously, this is a very relatable scenario, and that's all helpful information if we're, maintaining a Pokédex for cats. But the real magic of computer science is when we do something with the data we have, like counting the number of nicknames for each instance of our cat class, or alphabetizing them with a bubble sort algorithm. In fact, a bunch of functionality can be packed into a class if we just include some instance methods. Hi, I'm Sabrina Cruz, and this is Study Hall, Code and Programming for Beginners. We'll get back to cats soon, don't worry, but first we gotta think big picture. With any program, we have two basic parts: the data that we're working with and the code containing all of the instructions that tell us what to do with that data. Our program can get data from lots of places, like a spreadsheet, a database, a cat cafe, or user input, but how we organize and process that data within our code is up to us. Classes help us organize our program so that methods themselves can be packaged together with the data they need to function. The technical term for this is encapsulation, and it helps us keep our classes in our program neatly organized. A Java class is like a blueprint. In the same way that a blueprint is a template for a type of building or other construction project, a class is a template for a type of object or instance. Every blueprint defines a set of features, like doors, windows, or flooring, that everything built from that blueprint will have, and every class holds attributes that are specific to that type of object. So let's say we want to construct the perfect cat. This should be easy, because all cats are perfect. In the cat class from earlier, the attributes are everything you need to sort of build a cat, like color, age, nicknames, and aliveness. But templates don't tell you exactly what each building, or cat, will look like. Two buildings built from the same blueprint may both have doors, but one might have a wooden door while the other might have a metal door. And two objects instantiated from the same class can have different values for the attributes they share. One cat might be black and 12 years old, while another might be calico and 1 year old. Java objects have instance variables to store these specific values. If we instantiated or created an object called myCat, we can access myCat's instance variables with a dot operator that refers to a specific attribute, like mycat.age. If you want a refresher about how objects hold information, check out our episode on building classes. But Java objects can also do things, and instance methods are basically the instructions for the things they do. We've used methods a lot in this series to help us complete repetitive tasks, because they're a named block of code that we can call back to throughout a program. But instance methods aren't usable everywhere in a program. They're associated with a specific class. As part of defining our class, we can add code for one or multiple instance methods, and then all of our instances of that class will be able to perform those methods. For example, if we instantiated a cat object named Loki, we could call Loki.createChaos to use that method. Now, whatever the method createChaos actually does is up to your imagination, because cats are capable of so much chaos. Instance methods can depend on data stored in instance variables, but that's not always the case. Like, a cat's ability to create chaos doesn't necessarily depend on their fur color or name. A cat named Loki can be just as chaotic as a cat named Corn Dog. So if we write the createChaos instance method in our cat class, we can perform the exact same task with any cat object regardless of their traits. Instance methods are handy no matter what the scale of a program is, whether we have a few objects or thousands. And if we decide to change something about an instance method later on, we only have to make the change in one place and it will change for all our objects. This is the power of organizing a Java program into classes. Most classes have instance variables and instance methods wrapped up in a neat little package. And that encapsulation means that all of our changes and errors can stay organized as well. Let's consider one situation where instance methods might come in handy. Organizing elective classes that are being taught at cat school. For this example, we need to create a course class. Now, we could make a class, it would be funny once, but then it would become confusing nonsense for the rest of the video. So, course class. We'll start by defining the class. To do that, we write a template of all of the information we want our course class to keep track of, including the teacher's name, course title, tail count for the course, an array list of student names, and an array list of student grades. Next, we're going to need a public constructor method for our class. The constructor method allows us to instantiate objects of our course class from our main class, and it can take a different argument for each of the attributes in the template: teacher name, course title, tail count, student names, and student scores. Now that we have our class constructor, we can create a few different instances of the course class. For each object we create, we need to fill in the specific values that apply to one course. Let's instantiate one course object with the name Loaf101. It's labeled in the school's course catalog. The best practice here is to keep object variable names pretty short and sweet, so it's clear what they're referring to, but they're not complicated and prone to typos. To instantiate an object, we need to supply a bunch of values for the constructor parameters, like the teacher's name, Mr. Whiskers, and the full course name, How to Be a 10 out of 10 Loaf. You'll notice that each course object has a list of student names and a list of student scores, and the arguments that we supplied to Loaf101 are called test names and test scores. Rather than supplying all of the data for these array lists in the parentheses when we create a new instance of the course class, we can create and fill them with data in the main class. For a refresher, check out our episode on how to create array lists. So far, our course class helps us store data about all of these elective courses, but it doesn't really do anything with that data. To give our objects more functionality, we can create an instance method inside of the class. For example, it might be useful to be able to calculate each course's average grade so that the instructors know how their students are doing. So we can code a calculate average instance method and plop it right under our constructor method within our course class. Before we worry about syntax, it's helpful to think about what the algorithm or decision-making process for figuring out the average of a list of grades will look like, and we can do that with pseudocode. We can calculate an average by summing up all of our numbers and then dividing that sum by how many grades we have. So we're going to need to start with a sum that we will add to as we iterate through whatever array list instance variable was supplied to the student scores attribute of a course object. Now we can translate that into Java code using all of the tools we've learned in this series so far, like for loops and math expressions. You'll notice that we use the keyword this in our return statement of our instance method. And that's basically how we differentiate between the class template and the representation of an individual course object. In other words, this.studentscores.size refers to the size of the student scores list in whatever course object we're working with. Because of the this keyword, this instance method will be able to access data from any object of the course class. When we're working with class and instance methods, it's important to think about scope, or where in the program different variables can be used. Methods in one part of a program can't necessarily be used by other parts of the program, so we have to pay close attention. Specifically, we can't call instance methods on any object in a program, just instances of the class that they're a part of. As an example, calculateAverage is an instance method of the course class, and we can only call it on an object that's created from that template. So loaf101.calculateAverage would work, but mycat.calculateAverage would give us an error, because mycat is an instance of the cat class, not the course class. Honestly, that doesn't even make any logical sense, because what kind of averages would you calculate for a cat? And this is one of the reasons that we want to try and design clearly labeled classes that accurately model the real world, because that makes it easier for other programmers to understand our work. The whole point of of classes is to keep our data organized, so it makes sense that we'd want to limit the scope of instance variables and instance methods. But there are still ways to access and use that data in other parts of a program. When we call an instance method like loaf101.calculateAverage in our main class, we can assign the value that it returns to a variable. That new variable has a different scope that's broader than the course class. Understanding what code a method can access and what code can access that method is super important to using classes and instances effectively. And it takes practice to build this skill. Scope is tricky, and it's one more thing to think about on top of Java's syntax, algorithms, and all of the problem-solving skills we've been adding to our toolkits. Learning how to encapsulate our real-world data and problems using classes can be super powerful. And in this episode, sure, we use silly examples and just scratch the surface of what's possible by working with classes that have a couple of instance variables and just one instance method. But we're really getting into some deep programming functionality here. It's helpful to understand the ins and outs of how classes work, from instantiating objects to the scope of instance methods, so we can write clean, readable code and be a better part of the coding community. As your programming skills expand alongside the problems you're trying to solve, you'll be able to create more code that's organized, reusable, and easy to maintain. If you're enjoying Study Hall Code and Programming for Beginners and are interested in taking an online course and earning college credit, check out gostudyhall.com or click on the button to learn more. Thanks for watching, and see you next time.